G'day everyone. Today we're going to be learning about how to sum a geometric series. In this lesson, we'll be looking through the formula to sum a geometric series, as well as how that formula is derived, plus taking a look at a few examples to ensure that we grasp this concept. So let's get into it. So what we see here are two different formulas for how to sum a GP or a geometric series. Both will lead to the same solution. However, it's suggested to use one or the other depending on your value of R, which is the common ratio. So when R is greater than 1, we should, or at least it is recommended to use this formula. And when R is less than 1, it is recommended to use this formula. The reason being is because if you use this formula up here when R is less than 1, we're going to be dealing with negative numbers on the numerator as well as the denominator, and that can just lead to some situations where it might be a little bit more difficult to work out. So I would highly recommend that we stick to these cases here, but ultimately we will still get the same answer if we use one or the other. So let's just stick to this one up here, but keep in mind that you can sort of flip around the R to the n minus 1 and the R minus 1 on the numerator and the denominator. You can flip both around and you will land at this equation here. So in terms of how to actually get this formula and how to prove this, what we're going to do is write out Sn, which is the sum of the first n terms. So this is going to be A, which is our first term, plus AR, which will be our second term, plus AR squared, plus all the way up until AR to the power of n minus 1. So we don't have an AR to the power of n term because the nth term, because the first term is R to the 0. And so because we start our count from 0, our ending is 1 less than n. So what we're going to do is we're going to say this is equation 1, and then we are going to multiply both sides of 1 by R. And so that means we get RSN is equal to, sorry, I should rub this out, is equal to AR plus AR squared plus AR cubed plus all the way up to AR to the power of n. And we are going to call this equation 2. Now if we do equation 2 minus equation 1, what we get is RSN minus SN. And if we take equation 2, which is AR plus AR squared plus AR cubed plus all the way up until AR to the power of n minus 1 plus AR to the n, and then subtract that by equation 1, which is A plus AR plus AR squared plus all the way up until AR to the power of n minus 1. What we'll be able to see is that when we subtract these terms, we can see that AR cancels with the AR here, AR squared cancels with the AR squared there, and AR cubed will cancel with an AR cubed somewhere in there. The AR to the n minus 1 will cancel with this one, and what we're left with is AR to the power of n minus A. So I'm just going to write that. And then we can factor out an A as well as an Sn. So we factor out Sn on the left-hand side, and then factor out an A on the right-hand side. And we should be able to see that if we divide by R minus 1, we get the formula that we have up above. Now, how do we actually get this formula down here? Well, if we take a negative, factor out a negative on the numerator and the denominator, so if I take out a negative out of this expression, R to the n minus 1, we actually get 1 minus R to the n. And if I take out a negative from the denominator, we get 1 minus R. And then so these negatives cancel. And so we have a to the 1 minus r to the n on 1 minus r. So we can see that these two equations are equivalent, which is exactly what we had up here. But yeah, just as I said before, depending on whether the ratio is greater than 1 or less than 1, it will determine whether we should, or at least it's recommended to use one or the other equation. So now that we understand the equation and sort of how to prove it, we can begin to look into some examples. So let's get into that. The first example says find the sum of all the powers of 5 from 5 to the 0 to 5 to the 7. So this is going to be the sum of 5 to the 0 plus 5 to the 1 plus 5 to the 2 plus all the way up to 5 to the 7. So these look a bit like S's. Now 5 to the 0 is just 1 plus 5 to the power of 1 plus 5 squared plus 5 to the power of 7. We can do this in the calculator, but for the purpose of what we're learning about in this lesson, let's use the formula. So r is greater than 1, so let's use this formula. Sn equals a outside of r to the power of n minus 1 over r minus 1. So a we know is 1, r we should know is 5. We can see the common ratio is 5. So that means the sum of the first 8 terms, which is this here. So this is the sum of the first 8 terms, is equal to 5 outside of, it's 1 outside of 5 to the power of 8 terms minus 1 over 5 minus 1. 5 to the power of 8 is equal to a really large number. I'm not going to write that out, but essentially just plug this into your calculator, and what we get is 97,656, and that's our answer there. Our next example says find the sum of the first 6 terms of the geometric series 2 minus 6 plus 18 minus whatever. So in this series, we can see that our a, our first term, is 2, and our r is minus 6 over 2, which is minus 3. Or we could have done that r is 18 over minus 6, which also would have gotten minus 3. So we can see our r is less than 1. So we should use, this formula here, as it'll just be easier to deal with. And so we are summing the first 6 terms. So that means we are going to say it's equal to 2 outside of 1 minus negative 3 all to the power of 6 over 1 minus negative 3. So this is equal to 2 outside of 1 minus, now minus 3 to the power of 6 is equal to 729. And then 1 minus minus 3 on the denominator is equal to 1 plus 3, which is just equal to 4. So if I plug this in a calculator, what I get is minus 364. And that's our answer for this question here. Our next example says the sum of the first 4 terms of a GP with ratio 3 is 200. Find the first 4 terms. So let's translate the information that they give us. So they say the sum of the first 4 terms, so S4, is 200. And this is a GP with ratio 3. So R is equal to 3. So let's quote the formula of the sum of the first n terms, which is a outside of r to the n minus 1 over r minus 1. And this is given that r is greater than 1, which it is because r is equal to 3. So when we plug in the information that we know, i.e. that the sum of the first 4 terms is 200 and that the ratio is equal to 3, we get that 200 is equal to a outside of 3 to the power of 4 minus 1 over 3 minus 1. And now with this information, we can figure out what a is. So this is 200 equals a outside of, so 3 to the power of 4 is 81, minus 1 is 80, divided by 3 minus 1, which is 2. So we get 200 is equal to 40a. So that means a is just equal to 5. Now they ask us to find the first 4 terms. So we should know that Tn is equal to a to the Rn minus 1. And now when we plug this in, T1 is equal to, well, a, which we know is 5. T2 is equal to a R to the power of 1, which is 5 times the ratio 3, which is 15. And then T3 is just equal to T2 times our ratio, which is 15 times 3, which is equal to 45. And then T4 is our third term times the ratio, so it's equal to 45 times 3, and that is equal to 135. And that's our answer there. Our next example says find the formula for the sum of the first n terms of the GP 2 plus 6 plus 18 and so on. So that's part A. So we know that A is equal to 2, R is equal to 3, we should be able to observe that. So we're going to be using Sn is equal to A outside of R to the n minus 1 over R minus 1. So therefore Sn is equal to 2 outside of 3 to the n minus 1 over 3 minus 1, which is equal to 2, 3 to the n minus 1 on 2. Now these 2's cancel out, so that means our sum, very simply, is 3 to the power of n minus 1. Part B then says how many terms of this GP must be taken for the sum to exceed 1 billion. So for the sum to exceed 1 billion, essentially we are looking for the value of n for which Sn is greater than 1 billion, which is a 1 with 9 zeros. Or in other words, when 3n to the minus 1 is greater than 1 billion. Now instead of 1 billion, I'm just going to write 1b just to make it simple. So 3n minus 1 is greater than 1 billion. And then when we plus 1, so 3n is greater than 1 billion plus 1. Now to solve n here, we need to log both sides. And then when we log both sides, we can bring the n down here. So ln 3 is greater than ln 1 billion plus 1. And then divide by ln 3. And we get n is greater than ln 1 billion plus 1 over ln 3. Now when I put this into my calculator, I get 18.863. So in other words, n equals 19. So the question's asking how many terms of this GP must be taken for the sum to exceed 1 billion. So that means 19 terms, because this is the first whole number that satisfies the inequality here, where n is greater than 18.863. So I hope that makes sense. Our last example is an application of the content that we've just learned, and it reads, the town of Elgin grew quite fast in the 8 years after the new distillery was opened. In the first year afterwards, there were just 15 car accidents, but over these 8 years, the number of accidents doubled every year. So what we have here is a block of information that suggests that the number of accidents is a GP. And it's a GP with the first term being 15, because that's the number of car accidents in the first year. And the ratio being 2, because it says that the number of accidents doubled every year. So once we have this information, it should be fairly straightforward from here on. So part A says find the number of accidents in the 8th year after the distillery opened. This is essentially just asking for the 8th term. We should know that the formula for the nth term of a GP is a r to the power of n minus 1. So for the 8th term, we can plug in our information. And what we end up getting, if we just plug this into the calculator, is 1,920 accidents in the 8th year. Part B then says find the total number of accidents over these 8 years. So what this means is essentially the sum of the first 8 terms, because it's the total number of accidents over the 8 years. So it's the number of accidents in the first year, plus the second year, plus the third year, all the way up until the 8th year. We should know that the sum of n terms is equal to a r to the n minus 1 over r minus 1. So when we are figuring out the sum of the first 8 terms, we just plug in the relevant information. So 15 is our a, outside of our r, which is 2 to the power of 8, minus 1 over 2 minus 1. Plugging this into the calculator, we get 3,825 accidents. And that's our answer for part B. Part C then says, what percentage of the total accidents occurred in the final year? This is a pretty simple question. So the final year is the 8th year, and it's essentially asking for the percentage. So the percentage of the total for the number of accidents in the final year is equal to the 8th term, so the number of accidents in the 8th year, divided by the total number of accidents across the first 8 years. And so this is 1,920, as we worked out from part A, divided by 3,825, as we worked out from part B. And as a percentage, so if we plug this into the calculator and multiply by 100%, to 2 decimal places, we get 50.20%, and that's the 2 decimal places. So we can see that the last term makes up 50% of the total of the first 8 terms, or at least the sum of the first 8 terms. So this is sort of illustrating how quickly a GP can grow. So this is just with a ratio of 2, but obviously the higher and higher your ratio is, or the larger and larger your ratio is, the faster this series is going to grow as you move along each term. And so what you end up getting is that when you get to a larger and larger term, it becomes an overwhelming percentage of the total sum of the first however many terms. So I hope that this answer here of 50.2% can sort of highlight how fast a GP grows and how dominant the last term is over the sum of the first however many terms. So to recap in this lesson, what we did was we looked at how to sum a geometric series by looking at the formula and its proof, as well as taking a look at a few examples. If you have any further questions around summing geometric series, please do leave a comment and I'll be sure to get an answer to you as soon as I can. I hope you learned something. I hope it was all making sense. Do leave a like, subscribe, and see you next time.